Hello, guten Tag, bonjour, this is Ayman again. In my last video, I show you how to make a motion detector that detects the hand movement, and in this video, it will be based on the same thing, on infrared switch, and this switch, as you know, return only two value. So it return true or false. It return true if it detects something, and false if it does not detect anything. So what we want to do is to hack this and to make it a distance range detector. So it will return an analogic value, not only digital value. So the idea I have is to change the voltage in the input of this infrared switch. So it works on 5 volt. What happens if it works in 4 volt, in 3 volt, 2 volt, etc.? Will it change the behavior? Will it change the distance that it detects obstacles? Well, I tested that and does not work. That's very simple. Why? In fact, because the infrared switch, this one is composed from two LEDs, one emitter and one receptor. This is the emitter and this is the receptor. And based on the return back of the infrared light, it will return 0 or 5 volt. It will return 5 volt, 5 volt, 5 volt. When it detects something, it will return 0. But the problem, both two LEDs, the emitter and the receptor, are working with the same voltage. So if I change it to 4 volt, it's changed in both LEDs. If I change it to 3 volt, it changed in both LEDs. So it will always detect the distance as the same. So for him, this or this is the same. Whatever is the voltage, it will just detect that there is something. So what to do? What is the solution? The idea I have is to open the infrared switch, to cut the plus or the VCC pin of the emitter LED and to relate it directly to a PWM pin from Arduino. So I will give it an analogic pulse and the receptor will stay working with 5 volt. So I will hack it to make the emitter as analog and the receptor, it will stay with 5 volt. So I will not have this problem. Well, the idea is to open it. I did that. I make some surgery operation and I found the pin. It's simple to find it. This is the emitter and this is the receptor. The emitter has two pins, one plus and one minus, or one plus and one ground. The plus is the smallest here if you want to detect which one it is. So I cut it from the card and I solder it to a fourth wire. So here we have the ordinary 3 wires and another fourth wire coming from the VCC pin of the emitter LED, not the receptor, be careful. After that, the signal is the same and everything is the same. Only that fourth wire should be related to a PWM pin. Why PWM? To make an analogic pulse to that emitter. So we will play from 1.9 volt, that's the minimum of this constructor, to 5 volt, and that's the maximum. You can go ahead to 6 volt or 7, but it will only detect 5 volt. And we will store in which voltage it detects the obstacle. So if it detects it in 2 volt, that means it is too near to the switch. If it detects it in 5 volt, it is too far. And all this range, based on this range, we will calculate the distance in which voltage we put to get the obstacle. If we don't detect anything, that means there is nothing. Okay. So this is the schema. The VCC related to PWM, pin, and all the rest is the same. Ground, VCC. I added one LED here to see the frequency, and this frequency I coded it so it will light too fast when something is too near to the switch, and it will light slowly when something is too far, and it will be off, of course, if there is nothing. So let's test this thing and this idea. Let's come back here. After the surgery, I will sit with my hand. I put the LED in 11 and ground. Okay, so this is our infrared switch modified. This is our Arduino, some wires. If you can see my motion detector, and you will see how to wire it. And one capacitor here is just to filter the PWM, the frequency, to make stable current to the switch. So let's test it. So here we have one frequency. Here we have more, less. See? And it is continuous. And if you want to buy something to do this work, it will be about 13 euro. And that's it.